I'm Professor Kumar and we are at Galaxy Tutorials. Today we are looking at the first chapter of the science textbook of 10th standard CBSE. Chapter 1 is chemical reactions and equations. In everyday life, at your home, workplace, around you, lot of chemical reactions are happening which we do not realize and which we do not call them chemical reactions. The book gives some examples. Milk is left at room temperature during summer. We find the milk will get curdled and or you say the milk is getting spoiled. An iron tawa or pan or nail, something made of iron, of course, around your house, some stand, the stand below your air conditioner blower outside, some iron nail exposed outside, you will find knives, they get rusted, okay, with the atmospheric moisture. Third, grapes. If we keep grapes in a dish for many days outside, we see smell of alcohol and we say now the grapes are getting spoiled. Food is cooked. When we go to kitchen and cut the food, add spices, add the necessary fats, oils or ghee or butter, and we saute it, we cook it over slow flame, we fry, we find the nature of the food is changed. Food gets digested in the body. We have to eat food to get energy, and we have to eat at least 3 sessions: breakfast, lunch, dinner, with of course snacks in between. This food is digested by the body, and all the nutrients are obtained from it, and we throw out the waste. We respire. When we respire, we find we give out CO2 and water vapor, which you blow on a mirror, you will see the water vapor condensing droplets. All these situations are chemical reactions. We have just taken a few examples. There are much more. Okay? This was just to introduce you. Everyday life, most of the things in our life are chemical reaction or based on chemical reaction. Then, in activity 1.1, the book says that we take a magnesium ribbon. We take a magnesium ribbon. Magnesium ribbon. And we light it. So, with a flame, I light it. Okay? When I light it, and I keep a petri plate below. Okay? I will find that this will burn, and white particles will fall down or deposited in my collecting vessel. So, this is magnesium. This is magnesium oxide, or I'll write full form first since we are not with the formulas. Magnesium oxide. Okay? And you see it has combined with oxygen in the air with the temperature which it is burning is the high temperature. So we are finding that a chemical reaction takes place. So this is activity 1 in our textbook. Going further, activity 2. Activity 2 in your book is take lead nitrate solution and add potassium iodide solution. What do you observe? This was activity 1. In activity 2, we take lead nitrate solution and we add it to potassium iodide. Solution. What do you observe? What happens? Potassium iodide added to lead nitrate will form lead iodide and potassium nitrate. Potassium nitrate, my friends, looks like a sugar, transparentish. and potassium iodide was dark colored. So we see change in the color of the solution due to the reaction. So this was showing that some change has occurred. We can't see this. We'll have to test and find this out. But the solution changed its color. In activity 3, we take a flask, okay, and add, as the book says, in a conical flask or a test tube, dilute acid is taken. Take dilute HCl, hydrochloric acid, or dilute sulfuric acid, whichever like. Some acid has to be taken, mineral acid. Add, now there is acid inside this. Add zinc granules. Add zinc granules. We add zinc granules to it. The book says handle the acid with care or you might get burnt. Be careful not to touch the acid. And you can see what happens. Now, in this case, we will put a cork. And we will put a tube through it. This is the cork. This is the tube. What happens? If I take a lighted splint, if I take a matchstick, and I will see with a pop, I will have a pop explosion because hydrogen gas is formed which is given out. So if I take only acid and put the matchstick, nothing happens. If I only take zinc granules and put the matchstick, nothing happens. When I add both, they combine with it, they react, and then hydrogen gas is given out, which I can test by a burning splint. So this is how we see that there is change in state, zinc gets totally dissolved, change in color we saw in potassium iodide solution, evolution of gas, hydrogen is being given off, change in temperature, things become hot, things become cold. Okay, we'll be seeing that some reactions give out heat and some reactions have to be heated to take place. So these are basic characteristics of chemical reactions. Next, we will go for chemical equations in brief because that is what I'm going to teach you how to do as they keep coming. Okay. So 10 CBSE we are at, and the chapter, my friends, is chemical reactions and equations. Chemical reactions and equations. This is the name of our chapter. This is science. So we are starting the chapter after we have done the introduction. So first unit in this is chemical equations. What have we to study in this heading? In this, we have to study that in chemical equations, we have, first, we will have to use symbols of elements. So I will use sodium, potassium, zinc, chlorine, oxygen, etc. Symbols will have to be used. You will have to memorize first 20 elements in the periodic table, which will help you throughout the year. Okay? B, we show reactants. Substances which are on the left hand side are reactants. And we use a plus to show the reaction between one and the others. Products are written on right hand side. They can also be many products. and they will be shown with the addition sign separated. Fourth, we draw an arrow to show chemical reaction. So I have reactants, arrow, products. It shows the direction, what we started with and what became. If it is a double arrow, or we write it like this, it is a reversible reaction. And single is irreversible reaction. Reversible reaction can go in both directions. Irreversible cannot go back to the original state on its own. We will have to give it the additional changed conditions. E, give me attention so that you understand what I am doing. We have to write the states of the material involved. So solid, we write with a S. So zinc granules, zinc solid. L stands for liquid. So HCl, I have liquid. G stands for gas. For example, hydrogen gas. Gas is also shown by an up arrow. Okay, so I'll put it here only. We write gas because all have, and we mark an up arrow, it will escape, it is lighter than air, so we'll have to collect it somehow. Then we have aqueous, that is dissolved condition. So I have potassium nitrate aqueous, like this. It is dissolved in a solvent, that is water. Okay, it's not dry. It will not react if it is dry like that. So we take care of this. Lastly, we show a down arrow for precipitate. Precipitate is when the compound formed settles down, is insoluble, and goes to the base of, say, the test tube or the flask. So this is shown as precipitate. F, conditions are shown on and below the arrow. Now, for example, I will write here sunlight, and I will write here I need chlorophyll. So, unless these conditions are met, my reactants, that is CO2 plus H2O, will not become products, that is glucose plus water. So, this is how we have to learn all the shortcuts for writing the chemical reactions. Second, we have to balance the reaction. What is the meaning of balance the reaction? Balance of reaction means total atoms, or you may have group of molecules, which means same thing, atoms. For example, Na, or group, there are groups which are getting exchanged, like C carbonate. Okay, should be equal on both sides. My friend, matter cannot be created nor matter can be destroyed is the fundamental law. So if I have 10 oxygen atoms, my products in one product, multiple products, if I total, I should again get back the 10 oxygen atoms. Otherwise, it is wrong. To balance, first, we write number before the compound. For example, 2H2O. That means entire H2O. So I will have 4 hydrogen and 2 oxygen. or you may have number at the base of this. For example, H2. This means 2 hydrogen. You may have both. Okay, you may have both, like CO3 and twice. Okay, with some molecule which is say K2CO3 and a 2. So now you see, you have a number here which applies to the entire thing. You have a number here which applies only here. This number applies to C and this. As a result, this will become K. When I see the molecule is 2. Okay, carbon, I have 2 and 2, 4. Oxygen, I have 3 2s are 6, 2s are 12. This is how we have to count the numbers. Unless you learn this, you will not be able to balance nicely. Okay, we will be balancing when we are doing the actual equations. Some equations I will show you right now also, because there are only 3 discussed up to now in the book. And as we go further, we will also do writing further equations. So first we will see, and as we finish, we will have a summary of all the equations listed down, so you can copy them on a piece of paper so that it is easy for you to practice and you don't have to think which reaction will come, which I have to balance, will I be able to balance. So we'll make a grand chart of all the reactions which are required. Okay, so we will go to the second type, types of chemical reactions. So we are on the second set of knowledge in our book, types of chemical reaction. Now, my friends, we are trying to sort the reactions into certain types based on how they occur, what they do, so that it becomes easy to study and easy to predict what products will be formed. So we will start. The first one is combination reaction. Combination reaction. First type. In combination reaction, we have A plus B gives me AB. These are reactants. This is product. Now you can see just both are, there may be there may be 2, 3, they will join with each other and mostly a single product is formed. Okay, so this is how combination takes place. General equation, A plus B gives you AB. Match the column, one line answers, identify, look for this pattern. Example given in the book is calcium oxide, okay, solid, which is called slate lime, plus water, liquid, okay, gives you calcium hydroxide, which is dissolved, aqueous. This is called quicklime because it's solid, and this is called slate lime because now it has become a bit jelly-like. So quicklime or tuna, as you say, is dissolved in water, will form slate lime or lime water as you call, and we use it to paint the walls white, etc. And the pan wala, as you see, is applying on your pan when you go to a pan shop. Now, as you can see, A plus B gave me AB. So this is a type of combination reaction. In this case, heat is given out. Your book does not write, but I just inform you, heat is given out. It becomes hot to touch. That is why you have to dissolve this slowly with a wooden stick without touching, or your body will get burnt, and let it cool gradually. And that is why the panwala puts the quick lime in the leaves, those big leaves you can see, ties it with the string, puts it in a bucket of water next to his feet, and over a period of 2 days or 3 days, it keeps it there and removes the slake lime from there to apply to the pan. The heat has to be removed. If you took it raw, it will burn your tongue and organs inside. Okay, so this is how the combination reaction is there. The book says second one, burning of coal. So coal is carbon solid plus oxygen from the air we are using. We are not using other gases, and we will form carbon dioxide gas. Burning of coal. Okay, A plus B gives you AB. The